now I'd like to look at another plugin for Grasshopper that could be applied to our egg. This time we're looking at paneling tools. So I have three different studies that I'm going to quickly move through. Just as an introduction to paneling tools, what every set of panels has in common, and we'll look at the tab at the top, is that a particular process. So to create panels, as the name implies, and that's what you're doing, you need to first create a very particular grid, point grid. And it's not enough to just grab a series of points or extract points from a mesh volume. They have to be generated via the tools provided by paneling tools so that they are properly ordered. So there's any number of ways to do that, but no matter what you do, you have to start with a point grid that's been generated using tools within paneling tools. Once you have that, you can then either generate a 2D panel system or a 3D panel system. And as the name implies, 2D is a flat surface, either a curve or a surface, and panel 3D is something that has depth or volume to it. Other than that, there's really no limit. As far as I know, there's no way to truly panel a volume, a solid. So to do that, you usually have to interpolate the last portion. So you can reference a solid, as we're going to be doing. However, it won't complete the solid. There'll be one section that remains open, and you'll have to do that manually. But for what we're doing, that should be quite manageable. So the first thing I'm going to do is generate our points. And one tool I like to use is Intersect Curves. So this gives you a lot of control, and there's many ways to do this, but we're going to do Intersect Curves. And I'm just going to pull that out, and you can see it's looking for two things: curves along the u-coordinate and curves along the v-coordinate. So and that generates our grid, so that you can see the component here. So for me to do that, I'm going to move back into Rhino for a second, and I'm going to key in extract isocurve, okay? And then we need to select a surface, and then you can see as soon as you select that surface, it creates the curve, the isocurve rather, that will be generated. And just I'm going to back up a second. I'm going to select this and disable the isocurves so there's no confusion, right? So let's go back to extract isocurve and then select the surface. And you'll notice right now we're in the V direction. So up here it's listing V. We can hit T to toggle. So now it's previewing the isocurve that would be extracted in the U direction. You can also extract all, or rather, there was in the past. No, there we go, both. So if you select a direction, you can actually do both simultaneously. So I'm actually just interested in one or the other. So kind of get close to a profile view, and I will start creating sort of equally spaced. You can also, to generate these curves, you could also just contour the volume. So now that I have the U direction, I switch to the V, and and there's a much more controlled way to do this clearly, right? Because this is not exactly regular. But you can see what we have now is some approximation of the surface using just U and V curves. So I'll go ahead and, I'll keep the surface here. So now that we have this, we can come over here, And the first panel I'm looking at is the random grid. So it will take these regular points and randomize them, sort of shift them around. So starting, and this is the component that's in question, starting with the U direction, I will come over here to my curve component, right-click, and go down to Set Multiple Curves, and then start selecting the U or horizontal. Make sure I get them all. All right, and then they're highlighted in green. There we go, and I'll do the same thing with the V. Set multiple curves. There we go. Okay, now you're seeing that something's starting to happen. So once we have the U and V values, it produces a grid. And what I could do, I'll go back to parameters, and I'll just pull out those points so we can take a look at them. Let's see, bake that. So those are the points that are generated from the intersection, okay? Now if I take that same grid after it's gone through the random attraction component, it looks, as you would expect, different. So right, so you can even see that there's sort of clarity here is gone. So what that produces, if we look back at the next step, okay, so we have our intersecting curves which generate a grid that's been randomized. And by the way, that randomization was done with our grid attractors. So there are different ways to actually adjust the grid, manipulate it. It's not necessary. Often you don't do this, but I used the random attraction. So that's what this component is. But regardless, once you have a grid, at some point you need to panel it. And I chose the panel faces, the generate faces in 2D. Okay? So that's what we have here. And what it's calling for as an input is a grid, and that's what we've been working on. So I will bring the grid from that point all the way in. It also is looking for a panel shape, which I'm trying to think what I defaulted to. I defaulted to 0, so I'm setting it as just a straight panel. And finally, the surface. It needs a base surface, which I'm going to use our egg volume, okay? And then the result will be a series of faces that I believe are joined. So that's what you can see over here. We're going to bake the final product, and we get this. So you can see some things are happening here, which is fine. We can explode this and flip the faces. Because I have my back faces set to magenta, it's kind of a mess. So if I ungroup, I can just start to select these and flip the direction of each of them. And there's something really odd was happening here. I'm not sure why that was, where oh, I think so this has to do with the selection order actually of those curves. I started at the bottom and I worked my way up, and then there was one more curve in the U direction at the bottom, and I clicked that last. So that actually dictated the order in which those points were generated. So you have to take care in how you what order you select the ISO curves in. But again, this sort of generates a sort of crumpled effect, which maybe is interesting. You know, and you could use this to kind of further develop the surface. So the next one that we would look at is the diamond panel. So this is something that's a little more regular. What we can do, we can take, I'm actually going to be more careful in selecting the ISO curves this time, so why don't we clear the values so that's not in the way. And then we'll come up here to the diamond, and this time in the U, so set multiple curves, I'm going to start at the bottom and I'll move my way up. And vertically, same thing. We'll just work our way around. Okay, now we'll skip this. So we have our grid, right? And now I'm going to move the grid into, and even I'm going to bypass this to begin with. Let's not even talk about diamond. Let's just talk about a standard paneled volume. So from the point grid, we want to go into our panel faces. So again, we just need a grid, which we have, and a reference surface, which is down here, the B-rep, and I will right-click, clear out whatever was using, what it was referencing, which looks like it was already the egg. Set one and redefine it. And there we go. So let's go ahead and bake this to see what we have. Okay, so you can see that you have, not surprisingly, a series of planar faces that sort of are mapped based on the system of points. Okay, so the next thing I want to do is say, well, what if we adjust, not necessarily adjust the location of the points, but adjust their relationship to one another. So this is where I'm going to bring in our diamond component, right? So instead of going straight from our regular point grid to generate faces, I'm going to plug it into the point to diamond pattern, and then from that into our grid, okay? And what's interesting is that the points don't move, but the end result will be different. Okay. Go. Again, for some reason that's flipped. For now, I won't worry about that. So you can see what happened, right? With the same set of points, how it connects those points to create faces is what's different, right? And one thing to point out is that one sort of shortcoming of paneling tools is that oftentimes the panels themselves are not truly planar. In this case, this is a very straightforward example. Absolutely, they're planar. In this case, if we start to sort of adjust the view, you can see, and they're kind of actually interesting, but depending what the end result is in terms of fabrication, for example, this really could be a liability. But for our purposes, this is just fine. So one last thing with the diamond pattern. Now, and I have the component here, there is a way, and I'm trying to remember where it is. Let's see, it's under grid utility, right? So the grid utility drop down gives us ways to adjust a grid once we have it. And in this case, what we want to look at is the grid density. So that's what this component is, and simply put, it's a way to increase the number of points based on an existing grid. So all I did was plug in our grid, and I gave it a reference surface, and then finally a variable in both directions, the row and the column density, So I just kept them at 1, so it increases them by 1, I believe, or that's some kind of scale factor. So if I take that and I plug it in, and then I bake, again, the same volume with only adjusting the density, we get a somewhat different result. Right. So you see, I'll turn off, and this is without adjusting the density, and this is with the variable set to 1. So if I came in here, and I won't even add a slider, I'll just change this and see what we get. Again, you could only change it in one direction if you wanted. Okay, there you go. So that is the diamond pattern. Okay, so one last thing I'd like to do, and again we can go back to, I'll go ahead and clear these values to start with our original ISO curves, is looking at custom panels. And simply put, this is a way to reference a shape, a surface, a volume of some kind as the panel. And then within a given series of points, that panel can get morphed or manipulated based on where it falls in a surface. It's actually one of the more powerful tools that we have in this plugin. So we're going to start again at the beginning by referencing our curves. First the U, set multiple, and again we want to select this in a clear order. Okay, V. Okay, now once we have that, we have our grid. And I've done this a few different ways. What I'm using here is Orient to Grid. And this is in fact actually under the panel 3D options. There are also tools under panel 2D which do similar things. So for example, if I wanted to simply morph 2D, it's very similar to this tool, though it doesn't appear to be. What we're, at least to begin with, what we're really interested in for this walkthrough is just the first two inputs, which are grid, and then for the Orient to Grid component, the input is a pattern object, and it's a spiral. You see the little icon is a spiral, so it could be, yes, it looks like a curve, but it really could be anything. The Morph 2D is limited in that the input specifically has to be a curve. So, and there may be some flexibility to that, but otherwise they're very similar. You can really do, I think you can do everything that I'm going to be doing with Orient to Grid, which is under the panel 3D, right? So we already have the grid, and we're just going to start with the standard grid. And I have our density adjustment and our shift to diamond component. But let's first start with something, say, with a curve, right? I'm just going to draw a circle. And the scale really doesn't matter. The orientation doesn't matter. And then I will go ahead and set that curve and make the connection. And then go ahead, maybe I'll hide our initial volume and turn off the previews of this so we can get a better idea of what we're working with. Okay, well, maybe the best thing to do is just to bake it. Okay, so this is what you get, right? We have a curve which is converted to a face, right? So it's a surface, and it's arrayed within that point grid in such a way. Why don't we bring it to this direction just so we can keep going with it. So that's a curve. Now, say we wanted to do this with a surface. Do a corner-to-corner surface. We'll do something like that. And I actually want to go in and I'll trim the surface. So select cutting object. There. Okay. So rather than just a curve, it's now a surface that has a little more complexity to it. So I'll select my surface parameter, go in and set that, and then make that connection. Okay, now let's bake this and see what we have. Okay, so it's sort of the inverse of what we had before, right? And now you can see where it's starting to move in the direction of something that could actually stay a solid or easily become a solid and be printable, though you could easily make a case for printing this as long as there was maybe some kind of overlap. And finally, so this is still all 2D, and if we wanted to, we could take it to the next level and say, okay, we have a curve, we have some kind of outer boundary, and I'm going to give it some relief here and duplicate the edge. There. Right, so they're actually offset, and then loft these two. We're not going to simplify and try this, right? Direction, go ahead and flip it, and there we have this. So you have this figure, which is now three-dimensional. We just need to use our boundary rep parameter when we reference it. Go ahead and set, and then make the connection. So this takes that, and again, as it's done, adapts it to the grid. I don't want to bake it ungrouped. Okay, it's a little hard to read what's happening here, but you can sort of start to get an idea of what is possible. And again, this is regular, right? It's taking that single surface, and, or rather, boundary rep, sort of polysurface, and arraying it along this surface, which is somewhat regular, right? But it varies from top to bottom. Now you can, the next step is to introduce an attractor where at different points along the surface, the scaling and proportion of each of those units varies. So that's really the next step. We won't get into that today. But finally, when you're working with this, as I mentioned, you will still have to do some work to generate a solid volume. And you know, one obvious step is to go from the polysurface to an actual volume, so that when it's arrayed within the grid, it does create a solid. But regardless, and you'll notice with any of these, if we spin to the back, that it's not complete. And my advice would be, when you're, say, pulling out the ISO curves, make sure that they're regular. So you could just take one of these modules and copy it around to the empty location, join it, and you'd be ready to go. So that's it. That's paneling tools, and hopefully some of you guys can explore some of these tools. Okay, thanks.